Hello, my name is Dan Beard, and I wanted to take a few moments to um, share some thoughts with you about Jim Bassingthwaighte. So Jim was my advisor, but he was also my colleague and my mentor and my friend for essentially my entire career in science till now. And and I think, even after we lost Jim, I still think, every time I do something interesting, oh, I should tell Jim about this, or I want to show Jim this. Um, for those of you that are lucky enough to have worked with Jim or known him, I think you might agree that this is a fantastic picture of him, which I pulled off of the University of Washington bioengineering webpage. And I think it's a fantastic picture because he's got that smile on his face, sitting in his office, working on some science, working on what looks like indicator dilution simulations, indicator dilution experiment simulations. And of course, um, you know, if you walked into his office, he would probably want to tell you what he's doing and find out what you're doing and, help you, inspire you, and teach you something, learn from you. So we all miss him a great deal. I can spend hours recounting, the impacts of Jim's career on our field and on, my life in particular. But I want to share a couple of things which I think are kind of really instructive. I went back to Jim's first paper, at least his first paper that appears on Medline, if we can find it. And a lot of people may not realize, people who knew Jim may not realize that he was a physician. He was trained as a physician. He was trained as a cardiologist. He practiced medicine, and this is all before he wound up at the Mayo Clinic. And I'm not entirely sure how he wound up getting a PhD with Earl Wood, but I think he was just super interested in research. But his research was always motivated by clinical questions. So this paper is about, it's not the most groundbreaking paper ever, but what they're doing is they're using indicator dilution experiments. It's called the Stewart-Hamilton approach, injecting dyes into large vessels and watching how those dyes were diluted in time, so concentration time curves, in order to measure cardiac output. And what this paper was about was like looking at different injection sites and different measurement sites and worrying about whether pulsatility impacted what was happening. And this was on animal models, not human. But this is where Jim started doing science. Okay, thinking about not just physics of physiological processes. Jim's career was focused on mass transport, diffusion, permeation, advection, chemical reactions of species in the vascular system, in the cardiovascular system, but always with the eye on impacting and translating to the clinic. And you may know that in around the late 1970s, early 1980s, Jim established at the University of Washington this national simulation resource for simulating blood tissue exchange processes, so mass transport in the cardiovascular system. And this is the sorts of equations that they worked with, writing computer codes for simulating and analyzing data from indicator dilution experiments. Equations based on physics of mass transport and on biochemistry of the reactions and the processes which were being interrogated by the experiments. And I did a search on Google Scholar or PubMed, I don't remember, for myocardial perfusion imaging with MRI, and I found this paper from published a couple of months ago by Brown et al. And digging it, so this is a contrast agent based measurement of myocardial perfusion using MRI. And if you dig into this paper, they cite this paper by Peter Kellman et al. And the equations they're using and the code that they developed for this process. And of course, these equations and these codes you may recognize from the previous slide were actually developed and distributed by the National Simulation Resource. So even in 2003, Jim's ideas, Jim's codes are impacting and being used in the clinic right now. Not 2003, 2023. Sorry. Sort of bigger picture perspective. There was this meeting that happened. This is early days when I was a graduate student with Jim, so I didn't go to the meeting. But there's a series of meetings on cardiac modeling and simulation and analysis of cardiac function organized by Sam Sideman. And Jim wrote this paper called Toward Modeling the Human Physiognomy. And some of you might have read this paper, 1994. But this is the first sort of instantiation, I think, in writing of this concept, which became the word morphed from physiognomy into physiome. But just read the abstract, and I invite you to go back and look at the paper if you and you'll find so much of the ideas and concepts which were laid down. It's 30 years ago almost. Are exactly where we are in the field right now, and just read the abstract and think about the mission of the IMAG consortium, right? Using modeling and essentially multi-scale modeling to integrate knowledge. And obviously Jim is talking about multi-scale modeling here, even if he's not using the term multi-scale, because he's talking about integrating information from molecular biology, biophysics, medical biology, but also he's talking about how to strategize as a community, and how to share resources, how to share data, how to share codes, how to make things interoperable. So Jim pioneered so much of the thinking that is really impacting where we are in the field now. So just back to this picture. This is how I remember Jim. I miss him a lot. I think the field misses him a lot. I think many people miss him a lot, and I'm really grateful for the opportunity to, share these thoughts with you. Thank you.